Welcome to the online cafe order database design and operation overview. Programmers and end users view computer systems differently. For the programmer, there is data and data management, programs and functions, and a myriad of other intricacies of which, in a perfect world, the end user remains blissfully unaware. Coronel and Morris explained that any SQL-based relational database application involves three parts: a user interface, a set of tables stored in the database, and the SQL engine. However, the end user interacts only with the interface. The table and the engine provide the formatted information from the raw data stored in the database. This creates transparency between the information and raw data where the user is concerned. If we imagine a cabinet full of files, each file contains the raw data in a less efficient yet conceptually similar way that a database contains raw data. For the user, this raw data is meaningless because it would take weeks or longer to filter through the pages to gather data and create reports. Interface software can use views to create reports which quantify raw data into displays such as graphs and charts which the user can understand. Database users can view and edit data using a database management system, or DBMS, such as PHP-MyAdmin. This method of managing a database, while powerful, also lacks efficiency because it requires the user to understand how the database is organized, and in the case of some DBMSs, to understand and use SQL, or secure query language. The ideal way to interact with and view data is not through a database management system, rather user software such as a web page interface or desktop application to configure the data into useful information. Before creating database tables and populating them with raw information, an essential step in database creation is database modeling. There are two popular types of database model formats: the Chin Entity Relationship Model and Crow's Foot Relational Data Modeling. Both designs categorize and define the data contained within the database. However, the Chin ER diagram is a conceptual model, while Crow's Foot modeling presents a structural view of the data containing column name details. An essential skill in database modeling is understanding the rules of relational database systems. In 1985, Dr. E.F. Codd published a list of 12 rules to define a relational database system. The first two rules define structure and searching. Rule 1, all information in a relational database must be logically represented as column values in rows within tables. Rule 2, every value in a table is guaranteed to be accessible through a combination of table name, primary key value, and column name. These two rules are in action when searching the database for information. There must be a logical order, and there must be key information to use in searching. Another vital aspect to entity relationship databases is that every table must have a primary key. This assures a unique identifier for each table entry. As explained by Coronel and Morris, entity integrity is the condition in which each row, or entity instance, in the table has its own unique identity. To ensure entity integrity, the primary key has two requirements. All of the values in the primary key must be unique, and no key attribute in the primary key can contain a null. Database tables are logical representations of complex raw data. The column definitions describe the type of data contained in each column of the table, such as integer, string, or date. The row contains the data relevant to each column for the item entry. As described in the Chin ER diagram, there are customers, orders, and a menu which contains subcategories based on the type of product contained in each. Describing food products is a complex process. For example, a beverage has both flavor and size attributes. However, while each of the attributes describes the beverage to the customer, the size is the price determinant for the seller. Therefore, it helps to normalize the beverage data and make the database more efficient by having two tables for beverage information, one for size and price, and another which designates flavor, which contains a column to relate to the size ID. The database currently contains no views or virtual tables. However, an earlier version of the database contained a view for daily sales. Views are a way to access current information limited to specific tables, columns, and ranges more efficiently and securely than direct SQL queries. The limitation is that views can't update from the other virtual tables, such as other views or select joins where the query does not create a new physical table or update an existing one. There are 2 example triggers built into the database. One is set to update when the employee closes out the order. The purpose is to create a timestamp for order completion, which the software can compare to create a graph of the range of times from order to service. The other enables tagging customer survey results to the employee IDs along with the order IDs so that managers can work with employees and customers to improve the workflow, work quality, and customer experience. There are many opportunities for expanding the database beyond the current state based on the typical functions of similar businesses. As a beginning business, this model should serve to record information accurately and efficiently until the business grows beyond the needs served by the design.